Example 1. Friar Tuck rode 24 miles to the fair in Nottingham at a leisurely pace. He stayed too long at the fair and had to double the speed on the way back in order to get home in time. If his total traveling time was 9 hours, how fast did he travel in each direction? Okay, what makes these problems different from the ones we've seen before involving this is they didn't tell me anything about, like they didn't tell me what the rates were, they didn't tell me what the times were. And typically we get to use a single variable, right? And our goal is to get the distance equations, or distance expressions set equal to each other, they add up to some number like that. Okay, what's different about this is he rode 24 miles to the fair, and he went home, which means he rode 24 miles back home. Here's the situation, I know both distances, but if you read the problem very carefully, at no point does it tell us how fast he's going, right? Now, he went to the fair, so to fair, and then he went home. Going to the fair, he went at a leisurely pace. In other words, we don't know how fast, but he's going some speed. On the way home, he had to double his speed. So what's double?
2R.
2R is double the speed. Very good. Okay, and usually that's the only variable we're allowed to use, right? But since we know both distances, we have the extra added feature here where we're allowed to use a second variable in the time column because it doesn't tell us how long he traveled either direction either, does it? It does say altogether his total traveling time was 9 hours, which we've seen this about 60 times now this year. Total time was 9 hours, and some of us are still doing it wrong. And I've said it 60 times the right way to do it, and I don't know how else to say it. So, can somebody tell me the correct way to set up total traveling time was 9 hours? Anybody?
T and 9 minus 2.
Excellent, Austin. T for one, 9 minus T for the other. And it doesn't matter which one's which. If you know the total time, you put the total minus T for the second one. If you put T minus 9, you will get the wrong answer every single time. So, I've used the variable R to represent rate. There was a relationship between the rates, but I don't know either one. I use the variable T to represent time. There's a relationship between the times, but I don't know either one. The distances, both directions, are 24 miles because he went there and he came back. The same relationship between rate and time is there. Rate times time still equals distance. If I take this information on the top row and write out the basic fact about rate times time equals distance, I know that R times T is equal to 24. If I take the information on the second row, using the relationship rate times time equals distance, I get 2R times the quantity 9 minus T is equal to 24. And if I go ahead and distribute that 2R through on the bottom, I'm going to get 18R minus 2RT is equal to 24. And what you're going to notice here is that this object here, RT, is right there. And even though I don't know what R or T equals individually, I know that R times T is equal to 24, right? So I can do a substitution here, and just like that, I'm going to get 18R minus 2 times 24, because again I'm replacing RT with 24, is equal to 24. RT does equal 24. And just like that, the only variable left is R. So 18R, if I move the negative 48 across, becomes plus 48, right? 18R equals 72. R equals 4. What unit is that? For what?
Miles per hour.
Miles per hour. We know that because he rode 24 miles, time was 9 hours. The units in there are miles an hour, so miles per hour will be rates. Okay. Now, going back to my chart, there's 4 things here I don't know. It says, how fast did he travel in both directions? That's what it's asking us. It wants the speed going there, it wants the speed coming back. Okay, if I go back to my chart and see where R lies, it tells me rate to fair is R. So the rate to the fair is 4 miles per hour. His rate home is the other speed we want to know. What would that be? 8, because once we know what R is, we can just use the relationship there to figure out what the other thing is. 2 times R, 2 times 4 is 8. And as always with these types of problems, the final step is to answer the question they asked. So make sure you give me all the information they're asking for. If you want to know how much time did he spend going to the fair, like walking to the fair, we could have said 4 times what makes 24, so that would equal what? What would this time be here? If this is equal to 4, this has to be 6, right? And if this is 6, what does this equal? 9 minus 6 equals 3. 8 times 3 equals 24. Once you know an answer, it's very easy to go through and find all the other answers. But again, answer the question they asked. How fast did he travel in both directions? We've answered it here. How much time did he spend walking to the fair? How much time did he spend coming home? That kind of thing. So anything they ask, you have to be able to answer. But again, once you know an answer, it's very easy to find anything you need to find. Use the chart to translate what those answers represent.